All right, equations of lines. Now, you guys have had this in Algebra 1, Geometry, Algebra 2, and now you're going to get in Pre-Calc. Must be kind of a topic you use a lot later on.
It's incredibly important.
Heavy topic. Yeah, and
both heavy and hefty.
We get into calculus next year, and you're going to write equations of lines all the time. What's the equation of the tangent line? What's the equation of the normal line? Boom, 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 boom. So we kind of think this is important, that you should be able to do this and do it well. So there are a couple different equations of lines. The point-slope form, anytime they give you a point and it says, oh, the line went through 2, 3, or anytime they give you a point, I usually use this equation because it's got a spot you can just plug the point right in there. And then, of course, m is the slope. You just plug that in. But that's what I use. I know a lot of people just go right to this one, though.
Yeah, and the slope-intercept, there's really two important things. The slope is m, right? And the y-intercept, this is the y-intercept, is b. And those are the two things that you need to end up with an equation in slope-intercept form.
And anytime you're going to use like a graphing calculator or something like that,
That's
you're going to have to have it in a y== form anyway. So probably a good idea when any question says, write the equation of this line,
Yep.
you might want to put it in that
Even
form.
if you start from the other one, move
Right,
to this one.
right. All right, so let's try an example here. So write an equation. Since they gave me a point, I'm going to use that y minus y1 equals m times x minus x1. So again, just like we did with the distance formula, let's go x1, y1, x2, y2. In other words, label your parts, and then plug the x1 and the y1 in right now. So y minus, what was y1? Well, it was 5, equals m, I don't know what m is, so I'm going to put a box there like they did in elementary school. X minus x1, well x1 was 3. And so I need the slope, and I remember that the slope was change in y over change in x. So what is that? 1 over -5. So -1/5 is the slope. So it doesn't say what form it wants it in when you get done, so that's a very viable answer. I think that's a good one. Remember, the slope is -1/5, so you don't have to do that again.
Yep. Right, so another way we could do this is we could use slope-intercept form, y equals mx plus b, and we just figured out, remember that m is -1/5, so let's not kind of reinvent the wheel on that one. So I said before we needed the slope and the y-intercept. We're missing the y-intercept, so let's go find it. And we got m, another code here, m is good, and I'm going to contend that we have an x and a y, and that it doesn't matter which point we use. We'll just use 3 and 5, those are both positive, x and y. And we can plug in those three things in, and we'll be left with one variable b. So let's do that. Y is 5, equals m, which is -1/5, times x is 3, plus b. And then let's solve this thing.
We gave you some really nice numbers to work with, huh?
Nice.
So what is that, -3/5?
Yep.
So this would be 5 3/5 equals b. Is that cheap?
Perfect. So then it's really easy after that to put it into this form, right? So y equals my slope, which is -1/5, x plus b, which we figured out was 5 3/5 plus 5 3/5.
Or 5.6.
Or 5.6.
All right.
All right, I want to explain a variation of the problems that you just learned about in the equations of the line video, the beginning of it. And it's when the problem is given with, in this format, right, with function notation. So I want to kind of explain that, and then we'll look at how to follow the instructions here, which is write the equation of the linear function with the given conditions. Okay, so I'm given that f of 4 is equal to 6, and f of 6 is equal to -2. And what I need to pull out of this is the points x comma y, or x1, y1, and x2, y2. So to do that, what I'm going to do is think back to function notation and remember that inside the function here, inside the parentheses, is the x-coordinate, the independent variable. Right? So I can write the first part of the point, the x-coordinate, as 4, and then the y-coordinate, which is the output, has to be 6. So this is equivalent to saying, hey, one point on the line is 4, 6. We can do the same thing over here. 6 comma negative 2. Again, because this is the input, the x coordinate, and this is the output, the y coordinate. Okay, so now I have 2 points, I can find the equation of the line, and I'm going to use point slope form. This is a little bit different variation of it than what I think was just presented to you, but it just has the y1 moved around to the end, and it saves me a step. So we'll plug everything into this form, and we'll get the equation of the line. First we need the slope. M is equal to y2 minus y1, so we'll go negative 2 minus 6 divided by 6 minus 4. That's equal to negative 8 over 2, which is negative 4. Then we'll take that and plug everything into point slope form. So I get y equals negative 4 times x minus x1. We'll use the first point here. So x minus 4 plus 6. Simplify that. We end up with negative 4x. Negative 4 times negative 4 is positive 16 plus 6 is 22. So plus 22. And that's the equation of the line through those points. And so again, the way to approach these problems is just to turn that function notation into x1, y1, x2, y2.